Here we go. Welcome everyone to the session on question answering evaluation. We're here with our chair, Shane. I'll let you introduce yourself and kick off the session.
Hello everyone, I'm Shane. I am a first-year PhD at MIT and former machine learning scientist at Apple working on Siri. The focus on question answering evaluation. I think this is a very exciting topic right now for a few reasons, not least of which because many of the existing benchmarks are being beaten or trivialized to some degree, but by modeling efforts that aren't really convincing. Practitioners have shown they don't generalize, they don't cater to the full range and diversity of inputs you would see in more realistic settings for conversational assistants. So it's very exciting to see the works presented here today dive deep into the evaluation methodology and design, examine a more realistic and wider diversity of inputs, and closely evaluate QA systems' ability to generalize and derive calibrated predictions. Each of these directions are critical to the applications of real-world voice assistants. And in the case of our first speaker, this topic is very underexplored in academia while being a core challenge in industry. So without further ado, I'll hand over to Abhilasha Ravichander, a PhD student from CMU.
Thanks for the introduction. Let me just try sharing my screen. Can everyone see my slides?
All good?
Okay, great. Yeah, so hi, I'm Abhilasha, and this talk is about designing QA evaluations that take into account the people who will be using an application. So this is work with my collaborators, Siddharth, Maria, Florian, Ed, and Alan at the Language Technologies Institute, Carnegie Mellon University. So I want to start by thinking just broadly about why should we care about evaluating QA systems realistically? And the answer to some extent is that question answering has moved beyond this academic pursuit that we do in our labs, and it now affects technologies that millions of people are interacting with every day. So the stakes and responsibilities on us as NLP researchers is high. However, the traditional evaluations that we have constructed in NLP are typically not built to consider how a system will be used in practice. And this ends up leaving out the different ways that people want to use a system. But it's also not inclusive of different people who use a system. For instance, studies have shown that users with a wide range of visual impairments tend to prefer voice interfaces for their efficiency of text entry. And the needs and benefits to these different types of users gets left out when we use benchmarks, which are essentially one size fits all. And when we base all our decisions in NLP on performance on these standard benchmarks. So in this work, we advocate for context-driven evaluation. So concretely, we are going to study three kinds of practical user interfaces to QA systems. The first is ASR, or automatic speech recognition. And this is an important interface to study now because of the prevalence of voice assistants. The second is MT, or machine translation. And an example scenario where this is important would be when there's information scarcity in a language. So when a speaker of a language cannot find information in their language online, they may rely on a translation engine to query a knowledge source in another language. The third interface we study are keyboard interfaces, and a very practical scenario where this comes up is such. And the way we will evaluate QA performance in scenarios where the user question is like passing through this interface is by constructing challenge sets that represent the kinds of errors each interface can introduce into a QA pipeline. Challenge sets are external sets of instances designed to reflect a system's reliability. And the nice thing about using this kind of challenge set approach is that they can actually be used post hoc. So you can augment existing benchmarks with usability factors. And in this talk, I'm going to describe how we develop two kinds of challenge sets. So synthetic sets, which simulate user interactions with interfaces, and natural sets which involve real people. So in general, we advocate that dataset designers always try to use natural evaluations, but there might be scenarios where this is hard or infeasible, so maybe due to resource constraints. So we are going to describe how we constructed synthetic challenges that can act as a proxy for natural noise. And throughout, we are going to use XQuad, which is a subset of the SCAI 1.1 development set, as a benchmark. Okay, so let's get started with how we construct these challenge sets. Okay, for speech, to construct a challenge set based on speech interface noise, we use a TTS ASR pipeline. So a text-to-speech system will voice a question, and a speech recognizer transcribes the answer, and this transcribes the question, and this results in a perturbed question. But now text-to-speech is going to be well spoken, and it may be better spoken than most humans are. So for a more natural setting, we ask humans to voice the questions and have an automatic speech recognizer transcribe the answer. So how this might look is that a human might ask a question like, how much can tenofores eat in a day? But the actual input that comes to a QA system is how much can C in the forest eat in one day? Next, we look at keyboard interfaces. So for the synthetic challenge set, we randomly sample words in each question to perturb with misspellings, or we source common misspellings that people make on Wikipedia and replace those words in questions to get perturbed questions. Now, for a more natural scenario, which looks at misspellings in context, we ask humans to type out questions without looking, and this introduces some misspellings. So if it's how much can tenofores eat in one day, there's a misspelling on the word can. Third, we have translation engines. So for the synthetic scenario, we use back translation. So we translate the question into a foreign language using a translation engine and then back to English. For the natural scenario, we have professional translations into 10 other languages from XQuad, and we use an automatic translator to translate the question back into English. And how this might look is, so this is a question in Hindi which says, "Ek din mein tenofora kitna kha sakti hai?" And we see that there's a perturbation on the word tenofora because Hindi doesn't really have this silent C sound. Okay, so let's look at the results. So just to remind you all, XQuad is going to be our unperturbed test set, and this is the number that will come up in benchmark evaluation. ASR, MT, and keyboard are the three challenge sets introduced in this work, and they represent the three kinds of interface noise that we are studying. And we're going to be benchmarking the performance of four state-of-the-art QA models. So these are BiDAF Elmo, BERT, and Roberta. And what we observe here is that BERT and Roberta achieve the best benchmark performance. And actually, their performance is very similar to each other, with BERT actually doing only very slightly better than Roberta. But when we look at the challenge set performance, and again, just to remind, this is QA performance that takes into account the interface noise that is introduced in QA pipelines. What we see is that Roberta clearly outperforms BERT in all three cases. So what this suggests is that just looking at benchmark performance, completely divorced from real world context, may not be enough, and it might lead practitioners to make suboptimal decisions. Next, we notice that all three types of noise can degrade QA performance. And what this means is that such evaluations are necessary to get a better estimate of what kind of performance you'll be seeing from your QA system actually at runtime. And we also notice that speech in particular suffers severe degradation, and there are lots of factors that go into this. Our paper has a very detailed analysis, so if you're interested, please do check it out. So next we look at performance on translation noise. What we see here is that QA performance does degrade, but not by too much. And we suspect the reason for this is that our translations are from German to English. So what happens if we see, if we look at this for other languages? what we observe is that when you go to another language, QA performance can degrade sharply. And Thai and Arabic speakers are likely to get the worst performance out of English QA systems on this benchmark. What about keyboard errors? So we see that performance does degrade on keyboard errors. I'm not going to go into this analysis either for the sake of time, but there's a lot of qualitative analysis on all three kinds of interface noise in the paper. Okay, so far we have described the problem of interface noise and analyzed its effect on downstream QA performance. What about mitigating this noise? So we experiment with two strategies. The first is question repair, where we try to correct a noisy question. And the way we do this is we try to find candidate words from a given passage and replace it in the question. And this is feasible for QA systems where we know ahead of time which document is going to be queried, so we can extract such candidate lists. And there are scenarios where this is the case, like question answering over manuals or legal documents. A second technique is data augmentation. So we generate noisy training data using the synthetic noise generators we have developed. So for example, if we want to do data augmentation for ASR noise, we use TTS to voice the whole squad training data. And then we trained our models on both the clean and noisy data. And so what do these results look like? So we show that our mitigation strategies reduce BERT errors on interface noise by 31% on average. And we found that data augmentation with ASR was very helpful, and actually noisy inputs from a different open source ASR system could be used to correct mistakes by ASR errors, even for a commercial speech recognizer. So final takeaways. I want to mention that QA evaluations have to expand to consider context of use, because as we've seen in this work, the best performing system on a standard benchmark may not translate to the system that you should choose in practice. But the other important aspect I want us to reflect on is asking ourselves who are NLP benchmarks designed for, because the way we design benchmarks in NLP reflects decisions that will impact people. And the question is, what kinds of user needs and requirements have we said is important? So in this work, we advocate for a shift to a more holistic and user-centered evaluation paradigm that considers the requirements of the people who will be using our QA systems. So thank you. All the code and data is available on our website, noiseqa.github.io, and feel free to reach out to me with any questions.
Thank you, Abhilasha. Awesome talk. Maybe a very, very quick question. Did you consider at all trying these query perturbations for retriever models? I feel like they get degraded far more even than the reader models that you present.
No, we didn't try that, but that does sound like a good extension for sure. And things like question repair would just not work to recover from those errors.
Awesome, thank you.
Thank you so much.
Let's introduce our next speaker, Linqing Liu from University College of London.
Hello everyone, I'm Linqing. Let me try to share my screen. Does it work well?
Yeah, all good.
Okay. So let's start. Hello everyone, I'm Linqing Liu. I'm a PhD student from University College London. And today I'm going to present my work, Challenges in Generalization in Open Domain Question Answering. And this is in collaboration of Patrick, Sebastian, and Pontus. So open domain question answering is a task of answering natural language questions drawn from an open set of domains. Questions are usually factoid questions, and answers are usually named entities, dates, or numbers. Now, suppose we have two equally easy formed questions. For some reason, the model predicts the correct answer for the left one, but the wrong answer for the right. Why does this happen? It turns out that there is an almost the same QA pair existed in the training set with only minor difference in the preposition word. This is not the only case. In fact, the previous study from our group shows that in the three mostly widely used ODQA datasets, 30% of test set questions have a near duplicate paraphrase in their corresponding training sets. That means a considerable proportion of test data only test for easy memorization. And a variety of open domain models perform substantially worse on questions that cannot be memorized from training set compared with those overlap questions. Yes, now we know that model performs poorly on those novel questions, even if they're derived from the same questions. But why? For instance, here we have exactly the same pattern of question as a previous one, but model can get it right. And there are other forms of questions model gets wrong. We want to handle harder cases and go beyond simply stating the negative results. So in this work, we wish to explore which attributes of unseen questions make them difficult for the model to answer. In order to unveil the mystery, a simple start is to categorize the questions according to their textual features. Here, I wish to draw upon the beautiful compositional characteristics of human language. Given a set of training questions, the first kind of test question we already know is a paraphrase of those in the training set. We label them as overlap. For another condition, we argue that a good model should be able to understand the questions involving all previously observed facts and the structure, such as panda, national animals, and which country, even though they're combined together in a novel composition. And furthermore, the model also needs to handle cases consisting of novel entities that are not covered in the training set at all. So we label them as novel entities. In order to correctly allocate questions into their own category, here we propose to view each one of them as being composed of primitive elements, or say items. Just like the compound water is composed of its items, the hydrogen and oxygen. For the question, the combination of these items cover its main semantics. However, unlike water, which could be easily known its components, we need some further steps to break down the questions into their items. Here is a question, for example, who is the main character in Green Eggs and Ham? We first use an off-the-shelf semantic row labeling model to produce verb and semantic arguments. We also explicitly label wiki entities since they leverage crucial semantics in factoid questions. For example, the Green Eggs and Ham is obtained by another entity linking model. Lastly, the question word is trivially obtained by identifying the WH words. Here are also some other decomposition examples. Note that these structure slots are not always fully present. Based on the question decomposition, now we can formally define the three categories, but I'll skip for a little bit in sake of time. According to the definition and with the decomposed items, we first automatically collect as many eligible candidates as possible for each category. And then we employ expert annotators and ask them to annotate according to the following process. For overlap, annotators are shown the test questions together with its highest character level overlap training question. Here is the true and false example. For CompGen, annotators are given the most similar train test pair, but opposite to the previous step. Now they need to verify that the test question is not an overlap of the given pair. For novel entity, Now they need to accomplish two tasks. Task 1, the detected wiki entities are true wiki entities. Task 2, the detected wiki entities are not covered in the training set. With the categorized labeled data, we next evaluate the non-parametric models, which mostly adopt a retrieve and read framework, retrieving relevant documents, and then produce the final answer condition on them. We consider three models: DPR, RAG, and feed. We also include a recent QA pair retriever, finding the most relevant QA pair and returning this answer. Another paradigm is parametric models, which are directly trained with QA pairs without access to external corpus and store the required knowledge in the model parameters. This is a results table showing the exact match scores for models on all test set categories. Now, let's focus on the non-parametric models and see the results on NQ as an example. Surprisingly, the performance of all non-parametric models degrades significantly on the CompGen subsets. On the contrary, they handle the novel question entities comparatively well. The EM scores on novel entity subset are relatively close to their overall total scores. And let's move on to the parametric models in the second column. Performance drops significantly on both CompGen and the novel entity, but novel entity achieves relatively lower scores. And if you think about this, this actually makes sense, since for entities not seen during the training, parametric models will struggle to know enough about it. And from these numbers, we now have an initial understanding of the generalization ability of the models, but that's not enough. We take a further step to thoroughly examine what the underlying challenges is. So we focus on the generative QA model feed, since it achieves the highest EM score, and further use the NQ dataset as it has the largest annotated set size. So as I described in the prevalence retrieve and read paradigm, retrieval is the first step. So we first evaluate the top K retrieval accuracy for the widely used DPR retrieval. The difference in retrieval accuracy between CompGen and novel entity is relatively small. You can see from the table it's less than 1%, but are significantly lower than their overlap counterparts. It shows two messages. First one is the retriever performance is a confounding factor for the performance gap between CompGen and novel entity. Also, solely improving on the retriever would benefit the model greatly for the unseen questions. Although there are numerous questions, most of them can be abstracted into limited patterns, and the question pattern is obtained by replacing all wiki entities and the other unification process. We wish to figure out if the question pattern frequency in the training set will influence the model performance at test time. Therefore, in these two figures, the questions are grouped by their pattern frequency. The left one shows the EM scores. A clear message is that the model is more likely to make correct predictions for more common types of questions. And the right figure shows that for the three categories, their pattern frequency distributed similar to each other. It means the performance gap cannot be explained by the different pattern distribution. Since the question pattern is positively related to the model performance, a natural follow-up would be, how about the entities? So in the natural question training set, most frequent entities are country names, sports organization such as NBA, and the list of frequent entities are usually rare movie and books or some special concepts. I was expecting that the entity line would plot the same trend as a pattern line, but bam, accuracy is anti-correlated with the test question entity frequency. Is that real? I mean, it's not even consistent with the well-known difficulty of modeling long-tail phenomena. After a closer look, we believe it could be attributed from those following reasons. First, is about the passages. Passages retrieved for high-frequency entities are much more likely to contain type-consistent, closed negatives, and distractors. Second is about the question itself. For NQ, the existence of high-frequency entities could be indicative of an ambiguous question. Then, what about novel entities that the model has never seen before? We ran a simple ablation study on 100 novel entity questions. We replace the novel entity. So in here is I'll never forget you in these questions, and their supportive passages with feeling good, an entity that has been seen from the training set. It turns out for 73% of the questions, the predicted answers remaining unchanged. It sends a message that specific unseen entities are not the main bottleneck for the model to locate the desired answers. So here is our takeaways. We define, categorize, evaluate questions according to their generalization categories. And also we show that for non-parametric models, they struggle to perform compositional generalization, but they handle novel question entities comparatively well. For parametric models, they drop significantly on both CompGen and novel entities. And if you wish to improve the model generalization ability, we also identify key factors that you should focus on. The first is cascading errors from the retrieval component. Also consider about the frequency of question patterns and the influence of the frequency of the entities. That's all about my work. And thank you for listening.
Thank you, Linqing. Awesome work. I'm being told to hold questions for the panel, so let's move along to Jifan Chen from the University of Texas at Austin.
Hi, everyone, I'm Jifan, and today I'm going to introduce our work on using NRI as a verifier to validate the predictions from QA systems. And this is joint work with Ansel Choi and Greg Durrett. Cool, let's get started. So current QA system try to return a most plausible answer to users. However, the returned answers are sometimes unreliable. So for example, when we search who invented the first central processing unit through Google, and the answer returned by the Google is Federico Faggin. This answer seems plausible at first, but if I take a closer look at, we will see he actually invented the first commercial CPU, which is kind of different from the first CPU. Here's another example. When was Vancouver's last earthquake? And the answer returned by Google is 1946. But however, we don't see any information about last is given in the corresponding context. So can we really trust this answer? If we do a search, we'll find that there are more recent earthquakes that happened in Vancouver. So we see this answer is not correct. So facing such situation, one may ask, do we have a way to determine whether the answer returned by the QA system is correct or not? We'll try to answer this question in the rest of the talk. Our idea to tackle this problem is quite simple. We're going to use natural language inference, NLI, to verify whether an answer can be truly entailed from its corresponding context. This is an old idea and has been explored by several previous work. Here we revisit this idea with some of the recent techniques. Our general framework is as follows. For a question answer pair, we convert it to a statement, which acts as the hypothesis through a stage called question conversion. And for the corresponding context, we extract the most coherent part and treat it as a premise. We pass the converted hypothesis and premise to another model, and let it judge whether the premise could entail the hypothesis. In other words, whether the answer is correct or not. I will unpack each of the components here in the following of this talk. This talk is basically organized as follows. I will first introduce our pipeline, and then I will go through the experiments and finally the takeaways. Converting a question and answer pair to a statement is a non-trivial task. Dembski et al. 2008 has explored the use of a rule-based conversion system, but that didn't work quite well. In this work, we use a T5-based model to do the conversion, and it's trained on the annotations from Dembski et al. 2018. Given the question and the answer, we feed it to a T5-based model to get a statement, which we treat as the hypothesis. And through a narrow analysis, we find that the error caused by this stage is less than 5%, suggesting that the model is quite robust. With the hypothesis in hand, how do we pick the premise? We want to take sufficient context, but we don't want to feed a whole chunk of Wikipedia to the model. In this work, we pick the sentence containing the answer and decontextualize it from the context. The decontextualization phase basically makes a sentence stand alone out of its context by doing name completion, noun phrase and pronoun swap, and bridging, etc. So for example, here's the context from the previous question, and we feed the answer sentence and together with its context to a T5-based model, and it will replace the pronoun it with Venice, so we get the decontextualized sentence. And through a similar error analysis stage, we find that the error rate of this phase is less than 10%, also suggesting that the decontextualization is quite effective and robust. Once we have our pipeline, we can convert any QA pairs to NLI pairs. And to train a QA-NLI model, we can just treat the good answer and its context as positives, and the wrong answers in the top K predictions as negatives. So the same example is shown here. We say that it is actually a negative example because in hypothesis, it talks about the revolution period, where in the premise, it's actually rotation period. That's two different concepts. So the good answer is actually located in the first sentence, and we'll treat this hypothesis premise pair as a positive example. In this way, the model could learn that orbiting the sun actually means revolution period, and revolution period doesn't equal to rotation period. With the trained model, we now talk about our experiment. Okay, first, we test if an off-the-shelf NL model could help rejecting unanswerable questions. Here's our experimental setup. We train a QA model on SCAI 1.1, in which every question is answerable, and I tested on SCAI 2.0, which contains unanswerable questions. We use a NL model pre-trained on EMNLP to verify the predictions from the SCAI 0.1 model, which will always give an answer. And here is our results. EMNLP's model successfully rejects 78% of the unanswerable examples and accepts 82% of the answerable questions. And please notice that the EMNLP is totally out of domain regarding the task of QA, and it can do such a good job, which shows its potential to deal with the prediction confidence of the QA. We then test the NL model in a more general setting, which we call selective QA. And this means if our model can choose to answer only key percentage of the examples it is most confident about, what F1 score can achieve. The examples here are ranked by the confidence score of the model. For QA, we just rank it by the posterior probability of the answer span. And for NLI, we use the posterior probability associated with the entailment class. Here we have the similar experimental setup. We train a QA model on natural questions and test it on NQ and 4 out-of-domain datasets. We train a NL model using the generated NL pairs from natural questions and use it to verify the predictions from the previous step. Here's our results. The x-axis here denotes the number of questions being answered, and the y-axis denotes the corresponding F1 score. So first, we see large improvement can be achieved by combining NQ-NNI and the QA model. This might suggest strong negatives help the model generalize better in out-of-domain settings. So we'll also see further improvement by training together with EMNLP, and this shows complementary strengths introduced by EMNLP can help mitigate some of the biases of the QA dataset. And for more results and applications, check out paper for details. Okay, one interesting finding we observed by checking the disagreement between the NR model and the QA is that we find QA models sometimes return the right answer for the wrong reason. So here's an example. When was Clash Royale released in the US? And the answer given is the game Clash Royale was released globally on March 2nd, 2016. But however, does globally really entails the US? That's unsure, right? So we need further evidence to check. And also, the question is, who plays the bad guy in a good place? And the answer returned by the QA model is Ted Danson. But however, from the context, we don't see anything that Ted Danson or the guy he played, Michael, is associated with being bad. So we also need to check, is Michael really the bad guy? We need further evidence. Okay, so here's the takeaways. So through our work, we find that existing QA datasets encourage models to retain answers when context does not actually contain sufficient information, which suggests that fully verifying the answer is a challenging direction and worth exploring. Also, our proposed approach is helpful to locate the information mismatches between the question and the supporting context. And that's all for our talk, and thank you. Any questions?
Thank you, Jifan. I'm going to save questions for the panel again. So I'd like to introduce our next speaker, Vaibhav Adlaka from Mila at McGill University.
Hi, thank you for having me. Let me share my slides. Right. Hello, everyone. I'm here to talk about a recent work that I have done with my collaborators, Shehzad, Kahir, Ham, and Siva. And this is open domain conversational question answering with topic switching. This is very recent. It came out on arXiv just 2 days back. And we love to have any feedback that you have for us. So let me start by introducing what conversational question answering is, and then we'll move to our work. So conversational question answering can be thought of as an extension to the reading comprehension task, at least when it was introduced in 2018 and 19, where you're given a passage and you're having a conversation about it. So it's a series of question-answer turns in which the questioner is asking for some information from the passage, and the typically named as the information seeker, and the answer, who is the information provider, gives back the answer. The key thing to notice here is that everything here is based on a passage which is given to the system, and this is not a setting that we'll encounter in the real world. And to that end, there has been an attempt to make a conversation QA dataset open domain. And we asked the question here that what does an open domain conversation mean? Well, I think the first thought that can come is that we can let's say just remove the reference passage, and then we'll have a conversation, which does not rely on the reference passage, and it's up to the system to figure out which passage it is from. However, as you can see in this example, the first question can be a problem for this, because the first question are, what are the candidates running for? And well, that is just not resolvable right now. So previous approaches have come up with an approach to counter this, in which they rewrite the first question such that it is now unambiguous and it is possible for the system to evaluate the question on its own. You can see as the first question can be seen as an open domain QA question, whereas the other questions can be follow-up questions for that. But we ask the question, but what we ask in this work is that enough? Is it truly making the conversation open domain? Turns out that there are other properties of open domain, which is that it spans multiple topics or multiple documents during the same conversation. And there has been enough evidence that users span multiple topics within the same search session in their information seeking session, as well as human to human conversations have a lot of topic transitions between them. And therefore we feel that we can no longer adopt from existing datasets. One, because it makes the task a bit easier for the systems, in the sense if they retrieve the correct passage, the original passage on which the conversation is based on, they are done for the conversation. That same passage is used for the entirety of that conversation. And secondly, it's not close enough to the real world scenario in which topic transitions happen frequently. And for these two reasons, we set out to build a new data set and, starting from scratch and having a new collection process. So we had to incorporate topic switching and, involving multiple documents in our collection interface. So what you see on the screen right here is the interface that the questioner sees. And the questioner can currently just see the section titles of the Wikipedia document. But they cannot see the text, and this is what we call what is called an information seeking scenario. Now the key of enabling topic switching comes from the answerer interface. Now if you see on the left, that's actually a Wikipedia page in which we have retained the hyperlinks for other Wikipedia passages, which means that the answerer can traverse to various passages by clicking on these hyperlinks and search for the answer. And also to enable questioner to form questions from new topics, whenever answerer goes to a new passage, the questioner gets those passages in the visited documents section. And this enables to form a conversation in which topic switching is meaningful and semantically connected to the previous topics. And it also makes it open domain and topic switching. So yeah, this is a sample of the conversation that we have collected in our dataset. Our dataset is made up of 50,000 turns, about 4,000 conversations, has around 12 to 13 turns per conversation. So it is open domain conversational question answering, and as you can see on the left, the topic is different for a lot of the turns, and the topic switches from Byzantine Empire in the first question to an emperor Mehmed to the current capital of that country, which is Turkey, and some neighboring cities as well. So this we feel is now a challenging data set and a benchmark to evaluate open domain conversational question answering models. In our paper, we have gone into a lot of analysis of how topic switching happens. Do the annotators revisit the same topic? And what sort of questions can you expect when a topic switch has happened compared to when you are sticking to the same topic? For all this, I encourage you to go read our paper and give us any feedback that you have. We also evaluated the state-of-the-art QA models on this data set, and we checked with both extractive reader, generative reader, and GPT-3. And the retriever on both extractive and generative reader is the dense passage retriever. And we have also experimented with BM25 as well. But we are still far off from the human performance, as you can see, whereas we see that the generative reader is better than other baselines. We also go into detail about various ablations of retriever and reader, as well as some qualitative assessment of the results. Now, given the theme of this discussion, I wanted to bring to light some questions about evaluation in this domain. This is not a topic that we directly deal with in our work, but I thought it was a good venue to discuss this. So typically what happens in conversational QA and what is different from open domain QA is that we use the gold answers as an input to the model. And you can see the necessity to do that here. If you see the first question, who are the main cast of Twilight? And the answer is Kristen Stewart and Robert Pattinson. And the model answer can be, Robert Pattinson and Kristen Stewart in a reverse order. And many of the metrics that we use to evaluate, such as F1, sort of takes care of this. But at the same time, the second question, when it was collected, depended on the answer given by the human, and the question is, when did the first one start their film career? Now, if we give the input to the model as the gold answer, then we are probably on the right track, because we can compare the answer that the model gives with the answer that human gave. However, if we gave the model its own predicted answer, then there can be a problem, because the model might be doing the correct thing, but because we are using automatic evaluation, we might maybe judge that as incorrect. So there are some questions to be answered here, or some things to be discussed, is that although providing gold answers during evaluation is sort of required for automatic evaluation, but in doing so, we are not evaluating it in the real world setting. So basically, let's say as an engineer who sees this model and sees the scores, a high score might not necessarily translate to a good performance during production, when it is deployed in production. And just a thought that I want to leave with is that probably how can we improve automatic evaluation for conversational question answering? That's it for my end. Thank you.
Thank you, Vaibhav. Awesome work. I think we're going to the panel now. Cool. Yeah, thank you, all of you, for awesome talks and really, really interesting work. The very first question I'd like to ask is, what sort of follow-up work would you like to see directly prompted by your papers? And maybe this could also, for Jifan, include the question from Philip in the chat as a proposed direction of future work. Whoever wants to take that on first.
Probably let me go first. Okay, so basically from our work, our direct funding is basically if we can locate the information mismatches between the question and the context of the answer. So for example, just the example I introduced, the Clash Royale example. So basically, does the globally really means can entail US, or because those QA models, their parameters are huge, and there are many implicit knowledge are encoded in those models. Those models can just produce an answer without seeing the sufficient information, but it might be true, but what's the missing part? But if we can locate those missing part, then retrieve those, and they still will have an internal model or something like that to judge from the sufficient context to the question if it's truly being answered. That could offer another layer of robustness to the model, and also to users. For example, just when was Vancouver's last earthquake example? If we do a further retrieve to get those different years, the earthquake happens in Vancouver, we can get a better idea of whether the answer returned by the model is correct or not. So I think there might be a direction of a retrieve-based like a augmentation for the answer verification. So that might be a direction, I think.
Cool. Anyone else?
I can go
yeah.
next.
Please.
Okay. Sorry, Linqing. Yeah, so I think there's been a lot of focus on accuracy and like improving the performance of QA systems in general. I'm more hopeful to see work in this kind of orthogonal direction of usability. So, what would it look like if we actually interviewed users and saw what their expectations out of QA systems were? How will this affect our design of benchmarks, for example? So, for example, I've started working in expert domains, and a common problem that users have is that they don't have, there's a knowledge gap when they're asking the questions. So then QA actually turns into this kind of collaborative endeavor where you have to work with the user to converge on some meaning to figure out what they are actually asking. And I haven't really seen approaches like this in question answering in general. But of course, there's a lot of work in dialogue, which looks at things like this. More concretely, one of the pain points we identified in our work is spoken QA. And I feel that has also been neglected to some extent, even though there are resources now. But it's vitally important because there are so many languages without writing systems, for example, and so many speakers of languages who are not familiar enough with the writing systems. Like I'm not super comfortable with the writing system of many Indian languages. So it would be really helpful to have a greater emphasis in the NLP community to kind of work together with the speech community to develop more of these spoken benchmarks.
Awesome. So it sounds like the first step there is really collecting more data and making it public so people can work directly with it.
Absolutely. Yeah, that's vitally important.
Linqing, actually, I have a question for you. I'm very curious if your generalization decomposition strategy could be used outside of question answering, or how hard or useful that would be if we took it outside of just the question domain and applied it to other types of text, I guess, and tasks.
Yeah, I think an important component in our compositional generalization analysis is the question decomposition. So for ODQA, one of the most important component is the wiki entities. So we explicitly use the entity linking model to extract it. And then the arguments are there because it defines the other essential details around the wiki entities, like who is the main actor for the certain movie. And if it is applied to areas outside of QA, I think an important considerator is to how to define the component and how to decompose the questions into the items that is the most helpful and the most valuable for your own task. And for the other analysis, I think as long as we have the proper question decomposition, then the analysis should be easy to carry out.
And so the takeaway from your work, if I remember correctly, was not that novel entities are sort of the blocking point for some of these non-parametric models.
Yes.
But I was kind of left wondering, and I think you hinted at, but maybe you can highlight what are the main blocking points that you would like to see future non-parametric question answering models focus on?
So, yeah. So for the retrieve and read paradigm, we see that the retrieval model performs equally worse for the comp gen and the zero-shot questions. So I think this is definitely a part we should work on. And also for the compositional questions, we see that the model performance is positively related to with the pattern of the questions, which means we should come up with a way to make the model understand better for the real questions, I mean the tail question patterns. And also we show that the entity frequency is anti-correlated with the performance. So I think in Jifan's work, it also shows that when you have like multiple negative passages together, it works as a destructor and not as good, not as positive as we suppose it to be. So actually, we specifically we point out specific areas for the ODQA community to target, and I actually wish to see the following work either target one of the questions separately or a general solution to tackle them all together at once.
Awesome. Vaibhav, I have a question for your work actually, because I think that the main highlight was sort of the topic diversity that's in Tapika, or sorry, how do you pronounce your Tapioca?
Yeah.
Tapioca. I'm curious, because of that topic diversity, does that affect the model's focus on sort of the conversation context, or because it's switching so much, is that like less important? I wonder if you did any comparison to sort of previous benchmarks which weren't as diverse and all focused on the same context.
Yes, definitely. I think in our evaluation, the one thing that we have highlighted is that now the retrieval becomes significantly a difficult step for the retriever reader models, which is sort of also intuitive because previous benchmarks, at least most of the data sets, the majority of them are based on a single topic or let's say a single document. While there have been some works in which they change the answer to rely on other documents, but the essence of the conversation remains about a single entity, which also makes the task a bit easier for the retriever. Even locating a single or maybe a bunch of documents regarding the same entity, compared to changing the focus of the conversation every 4 or 5 turns to a new entity altogether, in which you are a new domain which is still related, but at least a bit far off from where you started off. So we also experimented separately retriever and reader, and in that case we found that retrieval has become significantly challenging compared to the previous open domain QA datasets.
So maybe a question for all of you, very open-ended, but I liked Svetlana's proposal. Just what is needed to make further progress in question answering, aside from what you've already mentioned?
Well, my belief is we need like dynamic benchmarks. There is already some work which is happening there, and I just feel that whichever data set or a benchmark is introduced should be regularly updated, also has multiple test settings, and should be able to get feedback from the users about what's a good or bad, what can be possible extensions, so that we can continuously make the task more closer to the real world and identify artifacts as much as we can.
Could you expand on that a bit? Is that sort of like just grouping together lots of different benchmarks for the same task, and maybe what Abhilasha was suggesting, include more diverse sources?
Well, that can also be one approach, definitely. And the way I was thinking was more about, like Squad came up and then Squad had some deficiencies and Squad 2.0 came up. And I just wish to see a more continuous process in this rather than, just like 2 versions in a way. And also have like we have discussed, multiple test settings where there is generic in-domain like in-distribution setting, and then there's composition generalization setting, and you can have various more types of settings for any data set. So that's what I wish to see more for every benchmark out there.
I think we have a minute or 2 left. I'm not sure. Anyone else want to weigh in?
I can go if no one else wants to go. So I think generalization is very important, as Vaibhav mentioned, and dynamic benchmarks are one way to go about it. So efficiency and usability are also, of course, important. The other thing that I think might be useful is to consider challenges that come up from application domains. So we have this tendency of using Wikipedia a lot because we have like, we know we won't be sued. There are permissive licenses and the data is available. But when you start working in applications, different problems come up and they can inform what we call basic NLP. So I would love to see more work being accepted in StarCL conferences on domain-specific QA systems.
Do you have some examples that you'd really like to see?
So for example, I've been working a lot with privacy, and that has like many different challenges compared to other QA systems. For example, so in Squad, if a question is unanswerable, it probably means that you've asked a question and you've got the wrong document to answer it or something. But if you have a privacy policy and a question is unanswerable because a privacy policy doesn't talk about it, that's actually very meaningful because it means a company is purposely leaving some practice out, and you should tell the user that this company is not describing it. And these kinds of challenges will come up with almost any application that can think of.
I think we're just about out of time, but thank you all again so much for such an informative discussion and presenting all your amazing works.
Yeah, thanks.
Thanks for having me.
Thanks for having me.
Thanks. Pleased to be here.
Just like to echo those thanks. Thanks to all the speakers. Thanks to Shane for chairing this session as well. We will be on the next broadcast for Svetlana's shared task. So we'll see you all there in a second. Thank you, everyone.
Bye.